Canadian Runway Friction Index, also known as CRFI for short. Prior to landing on a contaminated runway, we must know if that runway is safe to land. We must not only land, but be able to stay on the runway centerline after landing. Especially with a crosswind, it makes it even harder to stay on the centerline of a contaminated runway. That's where the CRFI comes in. The Canadian Runway Friction Index is a scale from 0 to 1 indicating how slippery a runway is. I've taken this chart directly out of the Aeronautical Information Manual, and if you pause this video, you can see that for each contamination, there's actually a range of the minimum CRFI you need for different contamination. Ideally, the higher the CRFI, as you get closer to 1, the better the landing braking is going to be, and overall the runway is going to be dry. So if you can, try to choose a runway on landing that has the best CRFI. Now, how is it actually measured? They use a decelerometer to calculate the CRFI, which is an instrument that measures the decelerating forces when brakes are applied. This instrument again has a range from 0 to 1, 0 being the least braking and 1 being the maximum deceleration on a dry surface. Now let's look at some practical examples using the CRFI that's combined with the crosswind chart. What is the minimum friction index needed for landing on runway 07 into the Ottawa airport? Let's say for runway 0725, the ATIS reports a CRFI of 0.30 and the winds are 110 degrees at 30 knots. So first things first, you have to figure out the wind angle. From runway 07 to a wind direction of 110, the difference is 40 degrees. So once you figure out the wind angle, you enter the chart from 40 degrees and you draw your line all the way down. Next is you take the wind speed, which is 30 knots, and you draw it along the wind line, which is the curved line. And now finally, you draw the line all the way down and you can read the CRFI, which is 0.44. So we need 0.44 CRFI. But the chart also tells you that the maximum crosswind that you can handle for this type of CRFI is 18 knots. So the minimum CRFI for an 18-knot crosswind component is 0.44 knots, which means that landing on this runway with only a 0.3 CRFI is quite dangerous and could result in uncontrollable drifting and yawing. So when you look at the ATIS, if it says 0.30, but when you look at the chart, you figure out the numbers, we need 0.44, then obviously we cannot land now because it's much below than what we need. Let's look at another example. In this case, we're asking you for a different number. We want to know what is the maximum crosswind we can have with a CRFI that's reported of 0.3 for landing on runway 26 right into the Vancouver airport. And the winds are blowing from 290 degrees. So once again, you got to figure out your wind angle. From runway 26 to a wind direction of 290, that's 30 degrees off the runway. You draw the line down. And now, because we have a reported CRFI of 0.30, we want to enter the chart from 0.30 and draw the line on top. And now we can see that the maximum crosswind we can safely land with is only 10 knots. So that's the number right above the 0.30 on the chart. It says 10. It's kind of covered by the line. And why do we do this? Because sometimes it's good to know what's the maximum crosswind we can handle based on the CRFI that's expected. Again, this is all for directional control, and these are two different types of examples you could get asked on your exam. Once again, in summary, a CRFI basically tells you how slippery a runway is. The closer you get to 0, the more slippery it is. The closer you get to 1, the better the braking is and the more dry the runway is.